students, welcome to part 2 of chapter 1, and we are going to get started here. Part 2, let me change the view. Alright, so after part 1 we learned about the history of computers, and so now we're ready for part 2. Part 2 starts out with a focus on the CPU and how it operates, and then we'll also discuss other pieces of hardware that interact with it. Part 2 will also discuss examples of software. Now let's get it started. We mentioned the CPU, or Central Processing Unit, in part 1. It is considered the brain of the computer. The more powerful your CPU is, the faster your computer can process requests. It is the most expensive part of a computer, and the entire system cannot function without it. Its function is to carry out arithmetic operations, mathematics essentially, and logical operations. Logical operations are when a decision is made around what the computer should do in certain circumstances or situations. We will get into that a little bit more later. This diagram of the CPU and the various components it interacts with, it includes several different parts of the CPU. Notice I list here the CPU, and then I have control unit, arithmetic logic unit, or the ALU, and the register unit. All work together to create the central processing unit, or the CPU. The ALU, or arithmetic logic unit, is where the mathematics is done and the logical decisions happen. Okay? The control unit is like the traffic cop, controlling signals and when they can happen. And then the register unit is an area where information is stored temporarily while the machine tries to do things. A program is loaded into main memory before it can be compiled. Over here is a picture of main memory. You notice it has these cells. These are storage locations, and they all have addresses. Here is main memory. It's always located very close to the CPU so that signals can be very fast. Main memory is connected to the CPU. See the light blue box in the diagram. Input and output devices are connected to the CPU to allow information to enter and exit the computer. To store something for larger periods of time, it is to be saved in the secondary storage device, such as a hard drive. And this is down here when you want to save something for a long period of time. If you lose power, everything in main memory disappears. Notice that the RAM, or main memory, is directly connected to the CPU. It's designed this way to help make the processing faster. If the signals between the RAM and the CPU had to travel across a longer distance, more time is required for the signal to reach each one. The difference is not easy to perceive until you start to run a lot of processes. Then it can be evident to the human eye. Main memory has location information called addresses that represent each storage cell. This is address 2001 represents this storage cell. 2000 represents this storage cell. 1001 and 1000 each represent storage cells. The address is used by the computer to locate where your information is stored. Anything stored in main memory is stored in machine language, ones and zeros, but we often represent them in hexadecimal values. Secondary storage is a device that stores information permanently. And I say permanently, but it's not exactly true because their systems, they do wear down and wear out. So, you know, the information could disappear, but we view it as permanent until we delete it. And typically, people will move information over to a new device when there's a risk that the old one is getting old and you might lose your information. Examples of secondary storage are hard drives or hard disks, flash drives, and CD-ROMs. Input devices allow you to bring information into the computer. We have several listed here for examples. See if you can think of another one on your own that's not listed here. Output devices allow you to bring information out of the computer. Typically, it's so that a human can view it, but not always. Sometimes output could be sent to another computer. Now that you understand what the CPU does and how it operates, you should have a good understanding about why it's so important for the overall computer system. Understanding the operations of the computer means you can be a better programmer because you can use the knowledge when you are designing or troubleshooting new software. Now we're ready for part 3 of chapter 1. Part 3 will cover 2 types of software and the language of the computer.